Welcome to the Deep Dive. We pull apart complex sources, articles, research, you name it, to give you the sharpest knowledge you need without all the hours of reading. Today, we're doing a deep dive into something that feels, well, really foundational: the global pursuit of clean water. And we're asking a pretty humbling question. What happens when the multi-million-dollar water treatment plant works, the pipes are perfect, the taps are flowing, but the community's health just doesn't improve like everyone expected?
It's a huge question.
Yeah.
And it's a critical field of study, especially in the global south. The study we're digging into today really, it zeroes in on the gap between access to safe water, which is a massive engineering win,
Right.
and the actual consumption of safe water,
Yeah.
right, at the point of use.
The moment you drink it.
Exactly. And it highlights this breakdown in the system that's often invisible. It happens right inside the home.
Okay, let's unpack that. But first, let's set the goalpost. Before we jump into this case study, what even is safe water to a public health engineer? It's got to be more than just, pure water.
Oh, absolutely. It's a total package. It's defined by 3 critical pillars, and they are absolutely non-negotiable.
Right.
If a water project misses even one of these, the health benefits you expect from all that expensive infrastructure, they're just not going to materialize.
Yeah.
Think of it like a 3-legged stool.
Got it. So what's the first leg of the stool?
The first, and the most obvious one, is health-related quality.
Okay.
This just means the water has to be microbially suitable, free of harmful pathogens, no fecal contamination, all the things that cause those terrible waterborne diseases.
That's the purity test. Simple enough. What's next?
The second pillar is accessibility. I mean, the supply has to be physically reachable without, undue hardship.
Well, what does that mean in practice?
Well, in the South African context of this study, the government benchmark is really clear. The source has to be within 1 kilometer of the dwelling.
1 kilometer, that's still a long way when you think about carrying water.
It's a serious physical challenge. Water weighs a kilogram per liter. So imagine carrying 20, 30 liters every single day. It's grueling work.
Usually done by women and children, I'd imagine.
Often, yes. So that 1 kilometer rule, it makes the engineering challenge feel very, very real.
Okay, so we have quality and accessibility. What's the third pillar?
The third is quantity. You need enough water. And not just for drinking, but for hygiene, for cooking, for cleaning.
Right.
The supply needs to be constant and available in sufficient amounts. The number they aim for is about 25 liters per person per day. That's the optimum.
25 liters. Okay.
So to put it all together, safe water is quality plus accessibility plus quantity. You need all 3.
Got it. With those 3 pillars in mind, let's go to the village of Folovhodwe in South Africa, where this study happened. I think we need to really understand the engineering success here first before we get to the heartbreaking part.
Yes.
So the researchers looked at a specific set of households they called the river group.
That's right. Before the project, these are the homes that got all their water directly from the river.
For everything. Drinking, cooking.
Everything. They'd haul it back in these big plastic containers. That was just daily life.
So on our 3 pillars, they were probably failing on all counts.
Exactly. The quality was questionable at best, access was a real challenge, and the quantity was limited by how much you could physically carry, which is why the intervention was so important. They put in a fully piped water distribution system, brand new communal taps all over the village.
The classic engineering fix.
A classic textbook fix, designed to solve access and quality in one go.
So let's look at the results. The engineering triumph. Did they hit their goals for access and quantity for that river group?
They absolutely crushed them. It was an undeniable success on those 2 fronts.
Okay, give me the numbers.
Let's start with access. Before the taps, the average distance the river group had to walk was 1,002 meters.
So just over that 1 kilometer limit.
It's just over. So technically failing the test. After the taps went in, that distance just plummeted
To what?
to an average of just 122 meters.
Wow. That's a 90% reduction.
It's a 90% drop in the physical burden. I mean, think about that. For the people doing that work, this was a liberation. It freed up so much time and energy.
From a kilometer-long trek to a short walk, you'd feel like a hero if you were the engineer on that project. You'd think, job done.
You absolutely would. And then you look at the third pillar, quantity, and it's the same story.
It went up.
Significantly.
Huh.
Before, they were only collecting about 18 liters per person per day. They were water stressed.
Below that 25-liter goal.
Right. After the taps were installed, their stored water went up to an average of 26 liters per person per day. Comfortably over the line.
Okay. So this sounds like a public health success story. They fixed the access, they fixed the quantity, The logical next step is that the quality pillar must also be fixed, and health outcomes improve.
That's what the theory tells us should happen. But this is where the study reveals just how fragile the whole system is. That goal of providing safe water, that crucial first pillar of quality, it wasn't fully achieved, even with the pipes working perfectly.
Tell us about the tests, the microbiology. Where was the water safe?
The water was perfectly safe right where the utility delivered it.
At the tap itself.
At the tap itself. The samples they took directly from those new communal taps were pristine. They met all the South African standards for drinking water.
And what's the key indicator they look for?
The big one is Escherichia coli, E. coli. It's the go-to indicator for recent fecal pollution.
And the taps showed?
Zero. Zero detectable E. coli per 100 milliliters.
So the whole upstream system, the treatment plant, the pipes, everything, it worked.
It worked flawlessly. The water leaving that tap was, for all intents and purposes, completely safe to drink.
So the system worked for 99% of the journey.
Now,
Where does the failure happen?
it happens at the final destination. The shocking result came when they tested the water inside the household's domestic storage containers.
The buckets and jugs in their homes.
Exactly. The water being stored inside the homes still showed E. coli contamination. In many cases, it was so bad it fell below the compliance level. It was unsafe again.
Wait, let me get this straight. The water travels safely through miles of engineered pipe, only to get contaminated in the last few feet of its journey, from the tap to the pot.
That is the ultimate last-mile problem, isn't it? They solve the complexity of the entire network, only to lose the battle right there at the household level.
That's almost unbelievable.
And it completely, it exonerates the utilities infrastructure. It shifts the entire focus onto what happens after the water leaves the tap.
So if the water at the tap is clean, the recontamination has to be happening between the tap and when someone drinks it.
Yeah.
How is this a behavioral thing?
It's overwhelmingly linked to what the study calls poor water handling practices.
Like what?
Well, think about the whole process. Unclean containers.
Yeah.
Putting the lid on the dirty ground while you fill it. Or, and this is a big one, dipping a potentially dirty cup or scoop directly into the main storage bucket.
And just like that, you've introduced contamination from your hands or the environment.
Instantly. The clean water is now sitting in a contaminated container, and the risk of getting sick comes right back.
That's such a powerful image, this huge, expensive engineering fix designed to deliver quality. And it's defeated by something as simple as not having a sanitary way to get water out of a bucket.
Exactly. Which led the researchers to wonder about behavior. They thought, okay, with this huge reduction in labor, that 90% cut in travel time, maybe that freed people up to focus more on hygiene.
Like having more time to scrub those containers every day, it seems logical.
It does seem logical. You spend less time walking, maybe you have more time for cleaning.
So did they? Did they use that saved time to improve their sanitation practices?
This is maybe the most surprising part. The study found that the reduction in labor did not translate into a statistically significant increase in the amount of water used for domestic tasks, like hand washing or cleaning.
So even though they were collecting more water overall,
Yes, up to that 26 liters per person per day,
they weren't using more of it for hygiene.
their daily hygiene practices didn't really change in a measurable way.
But that's so counterintuitive. It just shows how hard it is to change habits. They invested that saved time somewhere else, but not necessarily in better water hygiene.
It's a really complex socioeconomic puzzle. Habits are deeply ingrained. And maybe the priority shifts from labor to other household needs or economic demands.
And I suppose the pipes are a big, visible change. The need for sanitary storage is this constant, invisible battle you have to fight every single day.
Right, cleaning a container properly takes effort, it takes soap, it takes time to dry resources that might still be scarce.
So the end result is that E. coli is still in the water people are drinking. The risk of gastrointestinal disease is still there, which undercuts the entire point of the project.
It really does. The infrastructure succeeded, but the human system, the behavioral part, wasn't integrated for a complete success.
It shows that, the utility's responsibility or the planner's vision has to extend all the way to the point of consumption. It's a whole chain of custody.
It absolutely is. This failure to translate excellent tap quality into safe drinking water in the home, it just reveals a huge systemic oversight in how we plan these things.
This whole deep dive is such a humbling lesson for anyone involved in public health or engineering. It's not just about the big, expensive fix. It's about the small human details at the very end of the line. So when you look at these projects, I think the first lesson is that clean water delivery is an amazing feat of engineering. but it's only ever the first step. And second, the safety of that water is defined by its weakest link, which, as this study shows so powerfully, is often the point of use, the household's own hygiene practices.
And if we distill this down for planners or policymakers, there are really three fundamental takeaways they have to internalize.
Okay.
First, safe water requires meeting standards for quality, access, and quantity, all at the same time. You can't pick and choose.
They're all connected.
Totally interdependent. Second, just improving the infrastructure, even by cutting walking distance by 90%, doesn't guarantee better health if those poor domestic handling practices aren't fixed.
The recontamination problem.
Exactly. And that leads to the third point. Any intervention that focuses only on the engineering must be supplemented by a real effort to mobilize behavioral change around hygiene.
So the critical risk isn't the pipes breaking, it's the breakdown in sanitary custody right after the tap.
That's it in a nutshell.
Yeah.
And this failure, despite all that investment, it forces us to rethink how we approach that final step, which leaves a pretty important question for you to think about. Considering how much it costs to lay miles of pipe and how hard it is to change daily habits, should we shift our focus?
How so?
Instead of just relying on macro-engineering, should we maybe prioritize simple, low-cost solutions? Things like providing standardized, easily sanitized containers. Or, maybe even more powerfully, promoting small-scale microtreatment methods at the home level.
You mean like chlorine drops or a simple filter?
Exactly. A final, immediate, low-cost safeguard against recontamination right before the water is consumed. Because that, right there, might be the real battleground for public health dollars.